Hi, my name is Manish Gupta, and in this video, I'm going to talk about Google Gemini, a series of multimodal large language models from Google. Okay, so what is Gemini, right? And what is Gemini's architecture? How is it trained? So let's look at a few of those details. Gemini models are transformer multimodal decoders. So essentially, they follow the transformer decoder architecture and they are multimodal in nature. They can take any of these inputs, any of these modalities as input. So it could be text, it could be audio or speech, it could be images, it could be video, and they can actually generate images as well as text. There are three different sizes of these models, Ultra, Pro, and Nano. Nano models are specifically meant to be on device, while Ultra are meant to give you the best performance, best accuracy numbers. In fact, there are two sizes of nano models that Google has built, Nano 1 and Nano 2. Nano 1 is 1.8 billion, Nano 2 is 3.25 billion, depending on the size of the device. So, low performance device or other low resource device versus high resource devices. Nano models are also 4-bit quantized so as to suit these devices nicely. Now, why are these Gemini models popular? Well, because Gemini Ultra actually advances state of the art in 30 out of 32 benchmarks that they experimented with. I'll talk about a few of those benchmarks in this video. So these benchmarks, the 32 benchmarks include 12 text benchmarks, 9 image-based benchmarks, 6 video-based benchmarks, and 5 speech or audio-based benchmarks. And as you can see, on almost all of these benchmarks, Gemini Ultra model, the largest of their models, have resulted in state-of-the-art performance. Of course, Google never reported the size of its largest model, but it's looking at the kind of performance that they obtain, the size is surely going to be very large, right? Um, the other claim to fame for Gemini is better performance than human expert on the popular MMLU benchmark. This benchmark has been really popular since 2020, and it has been a very difficult benchmark to obtain human expert performance. But Gemini Ultra model has been the first model to actually obtain human expert performance on MMLU benchmark. Uh, just like MMLU, there is also a MMMU benchmark, which is about questions about images on multidiscipline tasks requiring college level subject knowledge and deliberate reasoning. Ultra actually also establishes state of the art there with a 62.4% accuracy on MMMU benchmark. So more about the training details. Gemini models use sentence-piece tokenizer. They have a 32K context length. So the large context length helps them essentially make best use of the different modalities of inputs. They of course use efficient attention mechanisms like multi-query attention. The videos are encoded as a sequence of frames. They typically use like 16 frames equally sampled from a video. The audio, they basically support audio signals at 16 kilohertz. So that's the kind of inputs that Gemini architecture supports. So how does Gemini perform on text benchmarks? So in their technical report, they actually compare against several text benchmarks: MMLU, GSM 8K, Math, Big Bench Hard, Human Eval, Natural to Code, Drop, HellaSwag, WMT23. Right. So notice that these text benchmarks cover different areas of text reasoning and understanding. For example, MMLU is about multiple choice questions in 57 different subjects. So that's a huge number of subjects which cover professional and academic exams. GSM 8K and math benchmarks are both mathematical benchmark datasets. Big Bench Hard has been known to be a pretty hard dataset, which is a subset of the Big Bench dataset, right? Then Human Eval, Natural to Code are essentially coding-based benchmarks. Drop is a reading comprehension-based benchmark. HellaSwag is a Commonsense multiple choice questions. WMT is, of course, the popular machine translation benchmark, right? Now, they compare with several models with GPT-4, GPT 3.5, which are, of course, popularly known from OpenAI. Palm 2 large, which is basically Google's own, largest model before this. Then there is Anthropic's Claude 2. There's Inflection 2. There's Grok 1, which is a recent LLM as well. And there is, of course, Meta's Llama 2 that they compare with. So as you observe on most of these benchmarks, Gemini Ultra actually wins across all of these that you see, right? Except for, let's say, HellaSwag, where GPT-4 is better. Okay. Now, the results that are reported here are a mix of several kinds of ways of evaluation. So, for example, some of them just use, in context, few shot kind of inferences, like 5-shot. Some of them actually use chain of thought, basically chain of thought kind of reasoning at 32, in the sense 32 different generations. So 32 different things that they generate from their beam using chain of thought, and they essentially, then they sort of, if there is consensus, they select that chain of thought output. Else, they basically just default to greedy search, just a single, a non-chain of thought kind of a way of generating output and come up with the final output. Okay, so the protocols for inference are different across several of these. But more or less, this is instruction tuned 0 shot, as you see. And then some of them use 3 shot, some of them use 4 shot, and so on. Some of them actually use this coherence-based consistency in terms of generation. So majority one at 32, come up with 32 generation, that there is consistency. Then you output the most consistent one, and so on, right? So, but then overall, you see that Gemini performs really well on various text benchmarks compared to the largest of the models. Now, a little more detail on how does Gemini perform on text benchmarks. So specifically on multilingual benchmarks, they, here is comparison, detailed comparison across high resource, mid resource, out of English or into English kind of settings, right? So as you observe for high resource, for mid resource, all of those different slices of multilingual benchmarks that you can compare with. This is on translation data, WMT23 translation data, and this is 1 shot performance. So you observe that, typically out of English, specifically Gemini Ultra performs the best. Into English, in the sense, let's say if you're translating from Spanish to English or French to English and so on, GPT-4 still has an edge, but all other slices, essentially Gemini Ultra performs the best. Right? Now, if you really look at also other multilingual benchmarks like Math MGSM benchmark, which is essentially a translated version of the English GSM 8K Math benchmark, you observe Gemini Ultra again gives you better performance, even compared significantly better compared to Palm 2 Large, right? Or GPT-4. For other two multilingual benchmarks, which are multilingual summarization benchmarks, ExcelSum and Wikilingua, again, you observe that Gemini Ultra gives you really good performance. Wikilingua Palm 2 is better, but slightly better, right? Now, there are four of these different models, right? Nano 1, Nano 2, Pro, and Ultra. How do they compare amongst each other? To make that comparison, they basically evaluate on 50 different benchmark data sets on these 6 different perspectives: factuality, long context handling, math, science, reasoning, or math and science kind of handling, summarization, reasoning, and multilinguality, right? So factuality basically means a retrieval kind of task or question answering kind of task. Long context basically means tasks which involve long kinds of input like summarization, retrieval, and question answering. Math science are about math problem solving, theorem proving, scientific exams. Reasoning kind of benchmarks are about arithmetic, scientific, and common sense reasoning. Multilingual benchmarks are of course around translation, multilingual summarization, multilingual reasoning, right? And as you observe, of course, the Nano model is not that great, but Pro and Ultra are really good. So, but if you really look at it, certain kinds of things, for example, factuality, the Nano model is not that bad compared to the Ultra model. While if you really care about math and science, yes, I mean, there is a huge gap between the Nano and the Ultra model. So depending on the application, you might want to, so essentially, depending on the application, you might want to consider which of these models make sense. Of course, Google has not really released these models as of now. These models have been just integrated in various devices like and different services that Google owns. But at some point, hopefully, these will be available for public consumption as well. So now for longer sequence inputs, essentially, they experimented with this interesting task called a synthetic value retrieval test. So the idea is that you have a large piece of text, and then somewhere in between, you actually include a JSON, so key value pairs. And then you basically ask a question, hey, what is the value for a particular key? Right. So essentially, randomly, have basically included this key value pairs in the entire bulk of 32K size text, 32K tokens size of text, and then you basically ask, hey, what is the what is the value for a particular key? Now, they observe that across several different samples, they observe 98% accuracy, which basically means that Gemini can literally process large token sizes and come up with very good accuracy across all of those positions. Here is another chart which basically shows how it can actually, how effectively it can process long sequences. So this is a chart which basically shows sequence position versus the negative log likelihood. So position of the JSON of the key value pairs in the entire sequence versus negative log likelihood. And you basically observe that the negative log likelihood sort of drops with increase in the sequence position, which again basically, and lower negative log likelihood is good. So it basically means that yes, Pro and Ultra, both of these models are able to care about long contexts as such. Lastly, they also did human preference evaluation. So they basically gave outputs from Gemini Pro and Palm 2 to humans and asked to rate on these three questions: creativity, instruction following, and safety. And again, as you observe, the win rates are more than 50%, which basically mean that Gemini Pro is better than Palm 2 across these three metrics as judged by real humans as well. Now, that was about text benchmarks. Of course, Gemini also works for multimodal inputs. So how about multimodal benchmarks? So again, the story is similar. You have several multimodal benchmarks, multidiscipline college level problems, MMMU, text reading on natural images. So text VQA is a very popular visual question answering dataset. Doc VQA, document understanding dataset, chart QA, understanding charts, infographic QA, understanding general infographics, not just simple charts. MathVista, mathematical reasoning. So this is basically, in fact, a benchmark consisting of several data sets, I think 28 plus data sets. AI2D, so science diagrams kind of reasoning, VQA V2, which is basically the most popular visual question answering data set. Okay. And again, as you see, here are comparisons of different models, Gemini Ultra, Gemini Pro, and Gemini Nano 2 and Nano 1, when compared with GPT-4V, which is the OpenAI's best multimodal input model, and other prior state of the art for these different benchmarks. Everywhere you see that the Gemini Ultra gives you the best results. And it's not that it is just better compared to GPT-4V, but it's actually also better than the Google PaLiX model, which basically is state of the art on several of these different tasks that you see here. Yeah. Now, how does Gemini perform on multimodal benchmarks? More details here. So MMMU is a multimodal, multidiscipline college level problems kind of data set. And it actually contains questions across 6 different disciplines. As you observe here, Gemini Ultra actually gives you better performance over GPT-4V in 5 of those disciplines. Of course, on science, it's not as good, but it is close. Okay. But on the other data sets, on the other subsets, essentially, it is better than GPT-4V. There are also results besides images. There are results on videos, on audios, and and also multilingual image captioning. Right. So this one is specifically on audio data set. So automatic speech recognition and automatic speech translation, those two tasks, and several data sets around those tasks. Automatic speech recognition is typically measured using a metric called as word error rate. Lower the better. And speech translation is measured using BLEU, the higher the better. And as you observe, again, compared to Whisper and USM models, popular models in these areas, Gemini Pro gives you better results. They don't report Gemini Ultra results here, but I'm assuming that Gemini Ultra is even better. Okay. These are results on video tasks. So specifically, there are video captioning tasks, there are video question answering tasks, and different metrics are reported here. So CIDR is the most popular metric for video captioning, so that's reported. Whoops for next question answering, this one, top one, accuracy for perception test, and the activity net QA datasets. Again, as you observe, Gemini Ultra gives you the best performance, even beating popular models like Video Lava and the Flamingo kind of models. Okay. Now, lastly, let me talk about multilingual image captioning. So, the idea is that given given an image with some Hindi text written on it, how well can it sort of come up with a good caption for that image, right? So, or come up with captions in Hindi or in Telugu and so on, right? So that's that. Now, these are the results essentially, as you see from Gemini Ultra 4-shot or Gemini Pro 4-shot, you basically see that on Hindi, it gives you better results compared to the previous best, their own Google's PaLiX models. Right? So, of course, they evaluated on these 7 different languages: English, French, Hindi, Hebrew, Romanian, Thai, and Chinese. Now, let me just show you a few examples of how well Gemini performs. More than Gemini, these are examples which sort of showcase how well deep learning has progressed in today's world, right? I'm sure some of you might have already seen some of the Gemini videos, popular Gemini videos. If you have not, there is a link at the end of this slideshow. right? So, but it's interesting to see how well these models can actually solve complex tasks. So here is an interesting physics question. And it is basically, it's a multimodal question. And here is an answer the student has provided to this question. And then the user wants to know if the student has answered it correctly. Now, the Gemini model actually first figures out that there's a mistake. So rather than saying mgh equal to half mv squared, the student has wrongly basically used mgl, where L is this and H is that, right? And therefore comes up with the correct answer also at the end. Okay, so that's a very interesting, application to solve these physics problems and help students solve them, right? Uh, Now here is a prompt, and this is also a part of the prompt. The image is also a part of the prompt, right? And then the Gemini model is basically asked to do several things. So look at the instructions in detail. So the idea is to basically say generate matplotlib code, put the 3D paraboloid subplot on the top left. So you want this to go to the top left. Put the tangent function on the bottom right. So it's about asking to rearrange this plot, right? So this guy should go to the bottom right, and this is the output finally, right? So this guy basically went to the top left, and this guy went to the bottom right. And for remaining two subplots, one of them should stay in its original position, the other should fill the last part. So it should stay in the same position. So this guy basically can stay in the same position, and this guy basically has to move, and therefore that guy comes there. Okay. So it basically, the prompt says first describe the plots and then generate code. So this is a description of those plots, what those plots are, and the code. Of course, I've not shown the full code in the paper, but this is the way it renders when you try to render it. Okay. So basically saying Gemini can actually do all of those logical, it has all of those logical abilities, recognition of functions depicted in plots, inverse graphics to infer code, instruction following to put subplots in their proper positions, abstract reasoning to infer that the exponential plot must stay in the original place because the other plot has to basically fill the last spot, right? Gemini can also, models can also do image generation. So although in the paper they don't really report their image generation capabilities, though they really don't compare with Stable Diffusion or any of those, popular image generation models. But well, they can do at least some level of image generation as explained in their videos and these examples. So, so this is a two-shot example. So in the prompt, basically the user says, give me two ideas that I could do with these two colors, blue and yellow. So colors I see, so the and the answer is colors I see a blue and yellow yarn. How about a cute blue cat? And then it draws a cat and so on, right? Now then these are the two two short examples. So shot one, shot two, right? And then the user basically gives a prompt, give me two ideas that I could do with these two colors, green and pink, and then Gemini model nicely comes up with this avocado and this pink bunny with green bunny with pink ears, right? So that's basically image generation. Modality combination, of course, you can actually give inputs with multiple modalities. For example, you could give input image, and then also you can give audio, which basically transcribes to this. What's the first step to make a veggie omelet with these ingredients? And then it comes up with this text output. Then you can follow up. You can basically again give an image, and then you can say, thank you for the instructions. I started making my omelet, but does it look ready now? Okay. Now that's a very, very popular question for people who are just trying to learn cooking, right? So it basically comes up with a very nice answer. Now you may not give any new image, but you can actually just talk to it. Why is it not ready? And then it basically says, and so on. So you can basically continue the multimodal conversation in that perspective. Chart understanding. So remember those questions in various exams where you're given these difficult to understand charts, lots of information, and then you have to consume that information and present it in a better manner or answer questions based on those. So that's what here's an example showing what Gemini can do. Spot a data point that stands out in these charts and what that implicates, then produce a detailed markdown table for all the data shown. So it nicely figures out that the data point that stands out is US, landfill plastic waste from US, which is 73%, which is basically this. And this is significantly higher compared to other countries and regions shown. So that is why it's basically explaining why this stands out. And then it basically nicely gives a table which explains the markdown table, which explains all the data. Okay. Multimodal question answering. So this has been a very popular task for a very long time, since 2016 almost, right? Do you know what is this plant? How do I best take care of it? So since 2016, VQA has basically seen many, many changes, right? Starting from just a answer classification to answer generation. Now we are at a stage where it can actually give us such a detailed answer. So it basically first understands that this is some plant and then gives significant details about, about how you can take care of this plant. Okay. Now, Gemini can also do interleaved image and text generation. So essentially, the prompt is just this. It's a text-based prompt. Please create a blog post about a trip to New York, but not for a human, where a dog and his owner had lots of fun. Include a few pictures of the dog posing happily at different landmarks. So by the way, these are pictures with the New York skyline right there, right? And the New York City and NYPD kind of cars and so on, right? And it basically writes a very nice blog also. So the text output, and there's also the images output, and basically nicely talks about things like Times Square and Central Park and Empire State Building and Statue of Liberty, which are all popular landmarks in New York, right? Image understanding and reasoning, remember solving these kinds of puzzles in school. So, 3-sized, 4-sized, 5-sized, and basically give it this prompt and basically nicely tells you the fourth shape should be a hexagon, right? Geometric reasoning. So you can basically give this kind of a question. Basically, you say find the height of the parallelogram given its area with 100 square units. So basically, X is what you're asking for. And it basically nicely correctly points out with appropriate reasoning why X is 5. So you could basically also give multiple images and this time ask a question, visual question answering with 2 images. So find a connection between these. So this is more like a multi-hop question answering on images in some ways now. So there's moon and there's a golf ball. So the model response is so awesome here. The moon is the only celestial body in which humans have played golf in 1971. Apollo 14 crew hit 2 golf balls on the lunar surface. Okay. Multimodal reasoning. So do you know the precise location where this image is? So the image is also, of course, a part of the prompt, and the model response is that yes, it's the Empire State Building and address for the Empire State Building and so on. It understands multimodal humor. So essentially, if you don't understand a comic, no problem. You can basically just give it to, you don't need to you don't need to feel ashamed asking your friend about it. You can basically just give it to Gemini and then tell it, hey, this is the comic. Can you help me understand the humor in it? And you can pause the video and read about the humor aspect here. Okay. Common sense reasoning in a multilingual scenario. So if you're basically given a multilingual, hierarchy kind of chart here, so family tree kind of chart here, you can basically also prompt it, explain what do I call my grandparents on each side of my family based on this chart. It nicely tells you on the father's side, you can call them as Yeye and Nai, while on the mother's side, you can call them those, right? Reasoning and code generation, you can basically tell it just like GPT-4. So several of these things that you see here are, of course, abilities that you also saw in GPT-4, their technical report, or other Sparks of AGI paper that folks wrote based on GPT-4 experiments. But the capabilities are actually pretty complex, right? So for example, you can create web apps now called Opossum Search, where there are several details. That every time you make a search query, it should redirect you to a Google search page with the same query, except that it should basically prefix Opossum in the beginning. It should also have a picture of Opossum, and then it should have powered by Google search written at the bottom. It should just be a single file, no JS or CSS files, and so on, right? It comes up with the code nicely, and then when you render it, the code basically gives you the right rendering as well as expected, as asked for. It can solve calculus problems. So you can actually have nice integration and derivatives problem solved. It can also understand videos nicely. So essentially, look at this video, yeah, and then basically you can prompt it, how could this person improve their technique? So basically, look at the goal again, and then it nicely says that, well, this guy needs to work on on their body positioning. Also, they need to work on the contact with the ball, the way they are making the contact with the ball, and so on. Right. So in summary, in this video, I talked about Gemini, which are multimodal transformer decoders for text, code, image, audio, video, processing PDFs, and so on. Right. So they put out three different members in the family. So Gemini Ultra, Gemini Pro, and Gemini Nano. Nano has 2 sizes, Nano 1 and Nano 2. Right, Gemini Ultra has been shown to be better than human expert on MMLU dataset and also established state-of-the-art performance on MMMU dataset. Right. So both of them are very popular benchmarks, and being able to establish SOTA on both of those benchmarks is something really considerable. Google already claims to have shipped Gemini as part of Bard. So when you're really playing with Bard, you're actually playing with the Gemini model. They have also shipped the Gemini Nano model on Pixel 8 Pro, and they seem to be using it for apps like summarization in the recorder app, Smart Reply in Gboard, and so on. They also have plans to basically make use of course, Gemini Ultra and Gemini Pro kind of models for improving search using the search generative experience, ads, and also in Chrome. Okay, so if you want to see more videos, there are several videos around demo videos from Google about Gemini. Have a look at that link. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my search on my homepage. Thank you.